morning, everybody. I hope everybody enjoy all the new features that Grafana team just showed us. And today I have one question. Most of us, right, have stood up a monitoring stack, configuring agents, trying to pull metrics, logs, traces, and all that, right? And we know how repetitive and time-consuming that could be, right? And at LiveRamp, Raj and I and other SRE engineers did the same thing, right? And we did it at a little bit bigger scale. We have to do it for many teams, many applications, many systems, right? And that becomes a lot of work. So before I jump into and talk about observability as code at LiveRamp, I want to tell you what LiveRamp is. Scroll down a little more, please. So LiveRamp is the data collaboration platform of choice for the world's most innovative companies. Our best-in-class enterprise platforms offers complete flexibility to collaborate wherever data lives to support a wide range of data collaboration use cases within organizations, between brands, and across our global networks of premier partners. But enough about LiveRamp, right? We want to get back to our journey. So what did we do? So at LiveRamp about a year ago, we started our journey to onboard onto Grafana Cloud. We use all the major products. We use Mimir, Loki, Tempo, K6, Synthetic, as well as the Grafana Alerting feature. And to do that for many teams that we have, it's very time consuming, and at times it's getting a little boring, right? We don't want to continue to do that. So we want to create a self-service model that any team can leverage and onboard themselves without SRE at LiveRamp having to go and do it for them. And I know that there are many infrastructure as code out there, like Chef, Puppet, Ansible, SaltStack, you name it, right? However, at LiveRamp, our infrastructure as code of choice is Terraform. So instead of setting up all the other stack, we decided to use Terraform along with the Kubernetes provider, mainly the Helm provider, for this project as well. So I want to walk you through our journey in implementing this observability as code at LiveRamp. So first, I'll talk about our main objective. What were we set out to do? And then I will show you the data pipeline that we created and implemented to meet one of those or two of those objectives. And then I'll show you the agent that we created in Terraform to meet the other set of objectives as well. And then Raj here will talk to you or show you synthetic monitoring from Grafana synthetic feature, K6 browser testing for performance testing and user emulation in a way, and then also alerting. And remember, all of these, we're doing it as code, right? That's the topic of this talk, right? We try not to do anything manually or repetitively. And so we have two main objectives. Our main objective number one is to minimize cost, right? We understand that metrics, we are charged by metric series. So a metric series is what? Is a metric name with all of its label and the different values of those labels make up a metric series. And a multiplication of all that make a metric cardinality, right? And a lot of metric cardinality, we get bigger bill, and we don't want that. That's one of the things that the Grafana team has mentioned earlier, that they want to cut costs for our customer or their customer as well, and we are their customer. And not just metrics, we have logs, right? We have debug log, error logs, application stack traces. Mainly, we worry about error logs, right? Info and debug and stack traces are just taking up a lot of storage that, a lot of time we don't look at. So it's a little bit of wasteful, and it costs money to store those things that we don't use. And so that's number one, but we have a small compliance requirement as well. We want to make sure that all the data we send to log metrics, traces, and everything, that flow to a Grafana cloud doesn't have PII or confidential information that we have. And so that's his number one objective. Number two objective is usability. We have a lot of teams. And we want to make sure that when we set this up, it's a self-service model. So we want it to be simple for teams to learn and use and repeat without having to have SRE explain every single thing. The number two is composable, right? Composability is having many smaller components combined together to create a bigger system or a more complex system. That's composability. And then extensibility, extensible. We want to make it easy and simple. However, we don't want to make it so extensibility kind of limit flexibility. We have to encapsulate a lot of stuff. So when we encapsulate things, it tends to make it harder for a team to configure it for their own use case, special use case, for example. And then the fourth one is maintainability. A lot of agents that since it's a self-service model, we set up in a way that is simple. So when it's simple, we have to have a lot of agents. And when there's a lot of agents, it will become less maintainable. However, I think we fixed that with what I'm going to show you next. But before, so to achieve our number one goal is to cut costs as well as compliance. I'm going to show you our data pipeline. Okay? So you see here on the left is LiveRamp, and on the right is Grafana Cloud. And at the LiveRamp side, we stood up a bunch of collectors. And this collector, we're taking metrics, so any kind of metric, cluster, pod, application metrics, etc. And then we have logs. And all those logs, application logs, container logs, they all go to these collectors. Same thing with traces. And we have several other agents as well that collects metrics from Prometheus endpoints, GCP monitoring API, and legacy application like StatsD. And when it goes through the collector's job is to filter all the data, right? So to meet compliance requirements and lowering costs, for metrics, we whitelist the metrics. If they are not allowed in the whitelist, or they will not be flowing into Grafana Cloud. And also, it drops all the labels that are not allowed as well. Same thing with logs. We drop all the logs that are PII, or debug logs, or application stack trace logs. It doesn't make sense to send them over if we're not going to use it. Similarly, same thing with traces. We remove the data inside of the trace itself, as well as query parameters that might have, name, address, information, and etc. So that is our cost minimization as well as compliance data flow. And to meet the second objective, which is usability, right? I'm going to show you how we design our agent so that it's easy, right? So the number one is simplicity. I mentioned earlier, simplicity, right? So we want to make it easier for teams. So we have these agents as well, again, one more time. Metrics, log, traces, and all that, right? And then several other agents. I think we have about 10 now, but all of them only need 3 data points: environments, teams, and region. So with these 3 data points, they are able to use Grafana UI to dissect their data, to create dashboard query, and make a distinction between all of those for their team. And simplicity, right? So it's short. I just showed you simplicity, but this is how it looks as code, right? So just the call to the agent code, and then the 3 variables, and that's it. simple. The second pillar of usability I mentioned is extensibility. Simplicity is good. I mentioned earlier. When it's simple, we encapsulate a lot. So when we encapsulate things, it limits the thing that we can customize. However, we do give the teams the ability to add more metadata so that they can drill it down easier or quicker, and more label do help with performance. Of course, when you have excessive, then it'll be costly, but we're not doing that. So we do give them ability to say project. Hey, what project, GCP project in this instance? And then also what cluster this is, what Kubernetes cluster. However, if that is not enough, we gave them the ability to specify any other metadata they want, right, through an attribute variable. And we even gave them the ability to customize everything about Helm, right? Helm release, Helm repository, Helm version, Helm tags, and all that stuff. And then we also give them the ability to override everything about the Helm chart itself, like inside of that thing. So whatever we pre-can for them and they don't like it, or they want to customize a portion of it with the way Helm works, any values that come after the prior ones take precedent. So with this override variable, they will be able to override everything that we already did that is not meet the use case. And here what it looks like in code, right? Same thing again. Environment, team, and region, all those are the three required variable. And then project cluster and attribute. They can name it, give whatever value they want. And then the Helm release information as well as the overrides. So the overrides, they can put whatever they want in there, and it will take over whatever we already predefined. And then the third pillar is composability, right? So I mentioned earlier, composability is when you merge smaller components and it make a bigger system. We have a lot of agents, so metrics, logs, traces, StatsD for the legacy application metrics, Prometheus to scrape from HTTP endpoint, as well as the various other agents. However, the team doesn't have to use all of this, right? They can choose whichever one they want. Hey, I don't need metrics, I don't need logs. I just want to support my legacy application. So they just install the StatsD agent. I just want to pull from Prometheus endpoints, just install the prom agent. So some of you will probably think, Chung, why so many agents, right? Why so much agent using up too much resources? The reason we chose to do it this way for two reasons. One, we're running in Kubernetes, so we're following the microservices paradigm. Is that mean one process does one thing and does it really well, right? And number two is separation of concerns. So what that means is when we have different agents here, if metrics agent falls over, my logs and my traces or my other agents are not affected. But if we put everything into one and that guy falls over, everything stops, right? And to answer the question about using up too much resources, we created all these agents with very low resource requests, CPU and memory, and the bare minimum for it to run. We do give it a limit of higher so that it can climb as much as it needs, but usually we don't see that problem. And the last pillar of usability is maintainability. I mentioned earlier we have a lot of agents, so that would be a lot of code, a lot of things to remember and updates and things like that for SRE. So what we did is we created something called common, right? So common is everything that all these agents use, secrets, all the outputs, all the variables, everything about Helm and things like that, they all have it. So once we put it into common and we symlink it to the agent itself, all the agents have the feature. We don't need to redefine them. We want to use the dry, which is don't repeat yourself convention. However, every agent is not configured the same way, right? So what do? each of the agent have its own set of files as well. So if a particular thing is needed for this agent, then we can define that file and put the required features or configuration for that agent into that file. And then we also gave them the ability to override whatever is in common with the Terraform features called override by appending the underscore override into the file name. And that will override whatever that we have defined in common. So this is how we structure our agent. Under common, everything you see in green there are shared between all agents. Right? We symlink them into the agent itself, which is in purple. You can see the only thing is we name it differently. I give it a common name in front. Terraform doesn't care how or like what file names or whatever. It concatenates everything, every file in a folder and create an execution plan from that. So as long as the file names are different, it will just consume them all and create an execution plan and run from there. And then we can see the files in black there is specific to that particular agent. And then the variable override or whatever underscore override is to override whatever we created in common. And this is another screenshot of the other agent, like logs agent and traces agent as well. So that is how we design our agent module to satisfy the second requirement, which is usability, simplicity, extensibility, manageability, as well as composability. And with that, I will pass it over to Raj to talk about synthetic monitoring as code as well.
Thanks, Chung. So as Chung mentioned, we are part of SRE team. So at LiveRamp, one of our main goals as SRE is to make it easier for our engineering team to adopt best practices. And this is not always an easy task. So on one hand, you have engineering team that do not really have the knowledge on all the individual components, and that makes up the infrastructure for a proper observability stack. On the other hand, you realize that different team, they have different priorities. So they don't want to know how to authenticate a task or any particular like Slack channel or PagerDuty integration with Grafana. They just want to know, or they just want to code their application. Have all the resources they need to create a synthetic checks or alerts or dashboards and get alerted when something goes wrong with their application. As simple as that. So that's why we invested a lot of time and resources to create the tooling necessary for many teams to get their applications monitored in less than a single day. So Chung already spoke how easy it was for engineering team to collect metrics and export to Grafana Cloud. So same experience we want to give to engineering team when we create synthetic checks or any other observability components. So let's talk about synthetic monitoring. So we know synthetic monitoring offers insight into the behavior of any service from an external perspective. It accesses the availability, performance, and correctness of a service. So the targets can be a simple URL, or it can be a website URL, or it can be even a server as well. So for an example, you want to check it out, the grafana.com, whether it is available or not. So you can set up synthetic monitoring for that. And in Grafana synthetic monitoring, they're even providing the SSL cert expiry also, and which is great. So let's talk about more on the challenges part. So when we were exploring the synthetic monitoring, we identified that there are a lot of challenges for our team, and those became our requirement as well. So let's see what the challenges were there. So we have like a lot of teams, and they're in a lot of regions, and each team manages multiple endpoints. Standardization. We seek to establish standards for creating synthetic check that are easy for the engineering team so that they can easily follow too. UI not preferred. So as a company and team, we prefer to employ infrastructure as a code approach whenever feasible, rather than relying on UI-based methods. And the last, we want to recover faster. So in case of any disaster, you must ensure swift recovery procedures are in place. So let's see what we have done to overcome these challenges and even for our engineering team to make their life easier, so that they don't have to code a lot or they don't have to know a lot of components. So Grafana, they have really good support, good Terraform support, so for synthetic monitoring. So what we have done, we have created all these modules for synthetic checks, which use the Terraform or Grafana based Terraform modules. And if you see on the right, so the engineering team, they have to just provide minimal information like job, target, methods, probes, and they have to just create a pull request, and boom, they have the synthetic check created. So it's very easy for the engineering team to just supply whatever actually they need, and behind the scene, all the complexities, we are taking care of that. So secondly, even to further expedite the process for engineering team, we have implemented a makefile script. So this script prompts for a team name, and automatically it will generate the folder structure, so which will have all the necessary files. So engineering team doesn't have to worry of all the supporting files required. And I mean so you can see an example wherein we have given the team name as DevOps, and what it'll do is it will create the folder DevOps, and then it adds the required files, and with that we have DevOps_prod.tf, which will actually have the implementation part. I mean the endpoints what the DevOps team they have to provide. So it's very simple. I mean that's the reason both these strategies make our engineering team work very simple. So when we are creating the synthetic checks, so it is essential for to validate the endpoints, either using public probes or private probes, depending upon the service functionality. So probes, what is probes? Probes are black box agent, which are actually responsible for executing the configured checks on a specific target, as I mentioned, URL or any service endpoints. So public probes, they are already provided by Grafana, but there are some internal endpoints which are required to be validated from inside the shared VPC. So for that, we need private probes. So when we are checking it out, we find, oh, we have a lot of shared VPCs. So we need a lot of private probes. So what we did, we have actually modelized even the private probe functionality as well. So teams are only required to provide the minimal information. So you can see here, they are just providing source, environment, region, and then how many instances of the probe they need, and they'll just create a pull request, and then the probes are already there. So they have provided 2 instances, and then 2 probes are there. So behind the scene, I mean, if you see for the engineering team, it's very simple, just provide some information. But behind the scene, we are actually doing a lot of stuff, which is creating the API tokens, we create the probe in the Grafana cloud, and then we deploy the synthetic agent on the cluster, which communicates to these probes and provide the result, and then only it becomes online. It comes online. So now let's move a little bit from service endpoint to K6 browser test. So we aim to conduct basic browser test and perform assessment on services using Grafana Cloud K6. So what we did, we devised a customized approach for creating K6 browser tests and scheduling cron jobs, as we didn't had any Terraform solution. So what we did, to achieve this, we opted for GitHub action workflows, as it offers greater flexibility and automation capabilities. So we established a foundational GitHub repository accessible to all the teams who want to create and run tests on the Grafana Cloud K6. So engineering team, they have to just provide the JavaScript file, and they have to just provide the JavaScript file which contains the actual functionality of the browser test. Behind the scene, we are using the GitHub Actions, and what it will do is, like, if we have a pre-commit hook to automatically generate the workflows, and which will have like a scrolling periodic execution also. So this workflows actually execute the K6 Cloud Run command, and it creates the browser test in the Grafana Cloud K6, as well as like all the information with what was required, like metrics, all these things will be available in K6. And furthermore, they can even configure alerting based on what all the information, or I would say the metrics which are exposed by K6, to have like enhancing like the proactive monitoring and then even the response capabilities. So now let's actually see like what exactly we have done. So here we can see the actual code. So we have the browser test, wherein actually the team will be creating the JavaScript file. So as soon as they create the JavaScript file, we have a pre-commit which is inside the hooks folder, and that script will create the workflow file for each test. So on the right side of the screen, if you see, we have the code, or I would say the template, which is created via this pre-commit. So it is using the K6, I would say like the base workflow file, and it uses even the file which was added by the developer, and it takes care of even scheduling the job also. So if you talk about the base workflow file, that actually contains the K6 Cloud Run action, which actually executes and creates the browser test in Grafana Cloud K6. So again, just want to highlight that the engineering team, they don't have to worry about a lot of stuff. They have to only create the browser test script, and automation behind will take care of all the things what was required, and it will run periodically Cloud K6. So very easy for the engineering team to set up. So yeah, next now let's talk about other important observability component, which is alerting. And as we know, the contact points and the notification policies, they are the pillar for alerting. So for alerting as well, we want to make a better experience for the engineering team. So we would like to be consistent on our approach. So what we've done, we provided the make file script so that automatically it will create the folders, and it will copy all the required files automatically. Also we want to provide the engineering team very simple structure, so that like they have to just provide minimal information, and it will take care of creating of contact points, notification policies, all the stuffs. So team can just simply list all their contact points. So it can be like Slack channels or emails and PagerDuty. All these things they can just add as a list. You can see like inside the local on the top portion, and it will automatically create all the contact points. And they don't have to worry about all the things which is happening behind. Like authenticating the contact points with Grafana, or even they don't have to worry about creating the webhooks or any other tokens which was required to set it up. So team will just give this minimal information, and it will be there. The same way for notification policies as well. So we have like default notification policies, which will have the label as team, and it will send all the notifications to that particular Slack channel, and they can even define the child policies, so which can have something specific to like severity critical, and then they want that to be sent to the high priority page duty, that will be done. So, all these informations are there. Even we have, in addition to the contact points and notification policies, we have even customized the template, the message templates. So if they want to change the message templates, they can change it. Or they can use the default template what is provided by the module, and usually like maximum team, they uses the default ones. So, and in addition to that, even they can create the mutes. Like, so over the weekend, they don't want any pager for any particular alert, they can mute it. So all these things are like done inside the Terraform project. So when we talk about like creating all these components via code, it offers a number of advantages that enhances efficiency, scalability, and reliability. So let's see like what advantages we got it. First, automation. So using code to configure Grafana components automates repetitive tasks, so which reduces the time and the effort required for setup and maintenance. So the team, they have to just focus on the strategic activities where they want to do it, rather than all other stuffs. Consistency. So code-based configurations ensure consistency across different environments and deployments. So this reduces the risk of errors that are actually very common in manual configurations. Version control. So by defining Grafana configurations as a code, you can leverage the version control system like Git. So this provides a historical record of changes, facilitates all the, like in case you want to like move back to the previous configuration, you can do that. Even it will help in tracking who made the changes and when they made it. Scalability. So configuring Grafana via code, it simplifies even the process of scaling monitoring solutions as your system grows. So you can easily replicate configurations across multiple environments and or even a different geographical region as well. So, and the next one is reduce human error. So automating the configuration of alerts and notifications minimizes the potential for human errors, leading to more reliable monitoring system and faster response time. And last but not least, disaster recovery. So, this is very, very important. With all configuration stored as a code, it is easier for backing up and restoring configuration and replicate them in disaster recovery scenario. So this ensures continuity of monitoring capabilities in case of system failure. So, we have tried our best to minimize the work, whatever, or even I would say like easier for engineering team. And we believe like we did a better, or I would say a good job in doing that part. And I think so like engineering team, they are quite happy with whatever work we have done. So with that, I'll pass back to Chung for a final closer.
Thank you, Raj. So looking forward, right? We started this journey about a year ago, right? So Alloy wasn't available, adaptive metrics wasn't available, adaptive log wasn't available, right? So we had to come up with something to accommodate or make it easier for our engineering team as well as us, reducing our toil in a little bit, right? So with Alloy and other adaptive features and ML and AI, we're looking forward to adopt those new features, especially in Alloy where configuration can be pulled from HTTP or Git, so we no longer have to manually or like have to apply the changes that we make to the agent module using Terraform. Because right now, if we make any changes, the team still have to apply those Terraform states into the cluster or into Grafana Cloud. So that's what we did to meet our two objectives of cost minimization, as well as compliance, as well as usability. And I would like to thank Daniel and Lisa for helping us with this presentation, and our CSM Matt Talarczyk for being our voice at Grafana. Thank you, everybody, for being here.